Okay, hello. So my name is Michael. I will be talking about this topic, so about automation in our projects, how we do that, why we do that, and maybe you can also use that because why not? Because it's not that expensive as we thought when we've been starting with it. So yeah, let's start with the main topics. So I will be talking on how we've started, why we've started with that, when we were implementing, like what costs, what made us try automate some of the processes that started to waste much of our time. How did we get there? So what technologies we have been using and why, and how did it work out? What were the problems and so on. And the main goal will be to show you how to turn a dumpster fire that is a lot of people putting too many incorrect assets and code and everything into the project into a better dumpster fire that has better UI and you can see the errors more clear and so on. So yeah, just something about us. We are from Warsaw, working remotely, which is of course part of the problem why it's more difficult to like go to someone and check their code from behind their back and check what may be the issue. Some of the things need clear checks and better like code security, for example. When we have like 8 developers, for example, working on the same project in the same day, and it's like a mobile project, for example, or some part of it, there are a lot of systems, all of them can break, and also, of course, because there are a lot of designers, artists, and so on, there is a problem that they also put a lot of strange things into the project. The art is like the least problematic. That the bigger problem is, of course, for example, incorrect data when it may seem that the build is working correctly, but it may not after you will release it to the players, for example, which may be quite problematic. If someone doesn't know, I'll be talking about CI CD tools. So continuous development and integration tools that we are using that are like free or almost free. That's why we are using them, of course, because costs are not our best allies. And those tools are mainly their goal is to turn your everyday regular tasks into something more automated. So, for example, if I know that I will need to prepare a build for my QA team, or I need to prepare a build because someone is like testing new data, for example, for our like characters in the game, like new statistics or something, I know that they will need a build for that. They are, for example, designers. They don't have a pre-programmed computer with everything installed, or we are moving to the new computer, for example, someone bought a new computer. You need to set up everything. You need to ensure that the builds will be working correctly. There will be no strange issues like, okay, it works at my site. I'm not sure why it's not working on your site. Why not automate it and put it like on a common device that will do that for you? And if it will not work there, that's more difficult to convince us that it's working on your site because like this is the same build for everyone. And we can chain those events, of course, because in CI/CD you can like set up those tasks. For example, check if the Unity is correctly installed, then prepare the build, do something with that build, send this build to someone. Maybe it's a development build, let's send this only to our QA team. Maybe it's like a production candidate, let's send this to everyone because everyone will be testing, for example. So you can modify how they behave. And in case of GitLab, because we like the visualization of GitLab and it's easier for us to track what's happening. Here, for example, is an example when we are checking if everything is correct with Unity, then at the end, like current stage, making some tests for those builds before sharing them with anyone, because if this is the place where something is not correct, you don't want to share and waste people's time for testing that. Then we are like making a final build, sending that to someone, and so on and so on, like deploy, for example, to the shop. You can like connect those parts as much as you want. You can, as you can see, you can have some common parts that will be then shared between multiple, for example, tasks that will be happening. So yeah, the why, Why did we decide on that? It's like there started to be too many tasks that were happening quite often, and we needed some like control on that. For example, making daily builds or making development builds for everything. Of course, something useful to have would be having the history of those builds. So for example, like when we are doing builds manually and we do weekly releases, for example, in mobile apps, it's important to have like a history, for example. So, okay, something broke and doesn't work on the stable branch. It should be stable. Something's incorrect, something passed all those tests. When did it happen? Yeah. So normally, like, okay, it was like I made last build last week. So let's check there. Yes. Now we have an automated pipeline, which not only tracks like every merge request, but also daily builds. So it's easy. I'm checking, okay, did it work yesterday? Did it work last week? If not, it's easy to pinpoint when the issue happened. For example, maybe it didn't work for last month, for example. No one noticed that, yeah? So that's really useful if it's happening automatically, because you don't need to remember about that. It's always, the more work you have at that stage, the more difficult it is to do that. Yeah, and of course, it's useful to allow other people in the team to be able to build something. So for example, art team added some new graphics, modified some assets. They want a test build for that. They can create their own branch, change those graphics, and test that without bothering any developers. And to finish that part, we did it because like we were working a long time in mobile games, so we thought, okay, if we're still making mobile games, also moving to like Steam on Switch ports, why not to try to do all those steps for all of them, because it will save us a lot of work, especially if we are like working a lot of with outsourcing. So we don't know a lot of those people we will be working with. We don't have too much trust with how this cooperation will be working. It's easier if some parts can be automated. We are working in an agile methodology because, for example, in those mobiles, it's weekly releases, daily stable builds and everything. So it's important to protect those main branches, not to break too much. And of course, it's, for example, useful to be able to separate without like remembering, okay, I'm doing this build for the QA team because something, I'm doing this for someone. There, I can automate, for example, that, okay, at 5 p.m., for example, every day, the QA team will get fresh from the development branch build for the next day to test. For example, when I have like a specific merge request, for example, that someone marks that is important, I can create a build from that and share to all platforms. There is some branch that I want just to ensure if it's working in general, I can, for example, execute only tests and not share it to anyone because no one will be playing that. Yes. So how did it start? Of course, first working with our initial projects, it was like a standard boring pipeline. So we've added some code, like with multiple developers. Everyone was creating pull requests because we are working with Git, because it's convenient for us and easier to track what the people are doing and who is like destroying the project. We are pushing something to a branch. We are creating a code. We are preparing a code review or not if it's like close to deadline. Of course, it was often that a lot of code was just passed to the main branch because, okay, hotfix, this will for sure fix something. We need to release that tomorrow, so let's do that quite fast. Then, of course, we needed to ask QA because no developers had that much time to test everything if something broke. Of course, it was often that the QA got the build and, okay, it's not launching, for example, or, okay, it launches, but like on the first screen when you get into the level, it doesn't work. So something must be incorrect. Okay, there was some line that someone commented, loading some data, for example, and we didn't notice. So yeah, that was a lot of wasting of time. Someone needed to build that, share that to people, and that QA needed to test that before we got the answer if it's working correctly. If it wasn't, that merge request was already like taking long time to be accepted. Like the code review mostly passed, for example. Someone didn't notice one line that was incorrect, so we were waiting like a couple hours, for example, because there were other builds as well. So we were wasting a lot of time for builds that shouldn't be tested because it's like waste of people's time. So we did the research. The research was successful. We looked for something that's like ready to use because we are not a big team. I worked with really complex CIs and CD solutions that were really cool, but you wouldn't manage to handle that because it's a lot of work and someone like needs to be then dedicated to some of them. We opted for something simpler. So like, let's mimic as close as possible the same processes we do normally, but with an automated pipeline. We found a game CI solution that is like on GitHub and is free to use. A lot of people, like over 1,000 people, are committing changes to that. So it's good. It's like prepared to work with Unity. So there were high chances that it will work with Unity. It's never like, you're never sure, of course. But we've tried that. We started with GitLab as well, because GitLab not only has the cool UI, I've and our team worked with GitLab a lot before, so it was like a go-to solution for us. We were starting at this point only with iOS and Android builds, so of course that was the goal, to build and do something with those builds automatically. We've selected GitLab because it has cool graphics. It's free for small teams, and for now it's free. Of course, here on the right side, I had like the statuses of what's happening, the name, the title of the pull request, for example, the information on what happened, whether it was successful, for example, with if a set of some actions finished with a correct result, everything's okay or not. For example, there is some warning because stuff. It may be like a warning that we will create because we don't want to accept something like, okay, there are some assets missing, for example. It's not critical, the build will launch, but it's not something we would want to push, for example, to the production environment. And of course, we've needed to learn some YAML, however it's called. So it's like another way of programming something, but for the pipeline, so we can set some stages. And for example, in such a stage, I can say that, okay, I have a preparation stage. In that stage, I will check if Unity has all the necessary like licenses, everything. Then, if it's correct, I will go to the next step. I will prepare, let's say, a build. And for that build, I will test if it's starting to work at all. And then maybe with this build, I will test if something is happening with it. Like I can load some data into it. I can check if, for example, the build size is correct, because if it suddenly drops between like a short time, it may be something incorrect. For example, like some addressables didn't build correctly because Unity. And we needed to first choose something called runners, because if we want to automate something, especially with GitLab, it's quite easy, but I need to decide where will I want to build that. So where those processes will be executing. Of course, it will be executing the Unity without the UI, but still Unity. So it may be quite costly when it comes to performance. We've started with the shared runners that are included in GitLab because they are easy, but there are limits you need to pay from some point. It's not that expensive, but we wanted to go for our runners as a go-to because it's more customizable. You have direct access. You can put scripts there easily. You can like connect device to that if something's really wrong with the runner, which happens sometimes. Like errors that don't say anything can happen only on the builder side. For us, it was convenient based on the like previous experiences to go to the second option. So started with shared runners, the built-in, and then bought a separate iOS devices that were attached as runners. It's quite easy to configure that. And normal standard Windows devices for building Android builds. Of course, you can use iOS for everything if you want as well. Second thing was just programming some stuff in YAML. It's easy because you just need to like define a step. So for example, this is the part where I will be building some Android. It's called something. Before that, I have stages that say, okay, first do this, then that, and etc. And then I can say that, for example, okay, this will just execute standard Windows script, a bat file. Or for example, now we mostly turn to PowerShell files because they are easier to move between devices. Like here, for example, and it will do some stuff like, for example, perform a Unity build, will execute without the UI, a standard building pipeline, for example, for Android. if it will fail, this part of the pipeline will fail as well. I will get that information back, and I can do that with do something with that. If it will not fail, it automatically gave me that result. So if it was, for example, Android build, I could just store this Android build and download it from the GitLab console, which is quite convenient, and also pass to any further steps if it's necessary for something. So for example, like that, if I prepared like I want only to build Android, this is like this small part, prepare Unity and build Android. It will finish with a ready build. So if it fails at this step, it would mean that it's not possible to build the project. So for example, there are compile errors, yes. So yeah, the biggest problem at the start, of course, it was like a couple of weeks, probably a month of learning this YAML, how to work with that, what kind of files attached to that, because especially that you have iOS and Windows and you want to build for Android and iOS devices. We've needed to come up with a solution that's easy to move between computers, our devices, our runners, also are ready to install when we're installing a new runner. For example, something breaks with the previous one. It was important to like minimize a lot of code, not to have too many dependencies on stuff that are not readily available from the start. For example, like in Windows, not all commands from the that we had in iOS were available in console and the other way around. So we've needed like look for the common ground. PowerShell was quite useful then there. When we've already learned that, like for new project, it's like around a week to set up everything, just to work with like initial setup, build, and perform some basic steps. And what else? Of course, there were some problems already at this step. We just came to the stage of like first stuff with pipelines. Of course, Unity is always a great engine. So for example, it sometimes because of reasons happened that with the non-UI mode, it was freezing because of reasons. Later on, we came to a like point that, for example, in iOS without the screen, it's really difficult to run a headless Unity. It's possible. It depends on the version. Sometimes you need to install a lot of additional stuff to be able to run headless a program that normally requires UI, and you want to run this on iOS without this UI. It may be problematic. For example, if with our first builder, it took us a lot of time, and we've decided, okay, if we will be repeating that with every next builder, we don't want to go that way. We've just bought a small screen and attached it to those iOSs. It was like faster. And also like things like if we didn't have a physical mouse, there were some like, for example, gameplay tests that broke because of reasons as well, because Unity was trying to get to the pointer and it didn't get the correct pointer from the window. So really strange things may happen with it, but we solved that. So yeah, we had some first results. There are like 4 examples what may happen in GitLab and how it's visualized. So I can, for example, cancel something. So first case. Second is when it's failed. It means that from those steps further, it won't execute unless I will tell it deliberately that, okay, screw that. If it doesn't happen, let's try do something further. Sometimes next step require the previous one to finish correctly. Almost often, I'm not sure if with errors, it's any time that I would want to proceed further. So it will break, and also it will not give me access to like results of this step. So if it was building, for example, a project at this step, the project will be not there. If it broke at the next step, so for example, generate results of some tests, I would have a build that finished, but it wouldn't have like those results, for example, or partial results if I would do this way. Of course, I want to go for the last one, so everything passed correctly. Not always possible, but useful. The main idea here and main benefit was that when we were preparing those, when we were working with those branches, so like all programmers push the code to the branches, work on those branches, test initial stuff on the branches, then there's a point where when we would want to merge that into the main stable version, of course, now those builds would happen automatically, and all code or just a final pull request, depending on the setup, would automatically build the project for Android and iOS and would check, okay, maybe someone missed some if Unity iOS part of the code and like attached Android Google libraries to the iOS. May happen, for example. Or something, for example, some data don't parse because some, I don't know, date time conversion problems. So at this step, we were able to detect the compile error. So this was the first step. Just try to build the project as it is. In the red, we can see that this was the big problem. The build process succeeding didn't tell us a lot, to be honest, because it was often that the build didn't start after that, because we had a build, but the data were incorrect and it was crashing at the start. Of course, we were handling that, but the game was unplayable at this point because it was not prepared. If everything went correct inside of the pull request in GitHub this time, because of reasons, I'll tell about the reasons soon. It was telling me that, okay, everything, all tests, automated tests passed correctly. This is the result. The pipeline tells me that I can merge that. It doesn't guarantee anything, of course, but it's a high chance that it will work. If, especially the more functions we will include in the pipeline, this is like a green light for the merge of this request. Of course, you still need to do the code review and such stuff, but from the pipeline point of view, it's correct. And you can also block those merge attempts so that no, like, junior coder that wants to push some code under the radar, they will be not able to do that without, for example, reviews and also passing this test. So they will need to wait for that. Ideally, they would also install the resultant test, but this is the difficult part. So yeah, at this point, we were able to just build something, download this file, the final file from the builder, from the GitLab's artifacts. They are automatically pushed there if I will tell them. We didn't need to poke like the developers for every next build. I need a build like in 5-15 minutes from this branch because we are doing something with that testing, for example. Now, even someone using the GitLab console could execute the same pipeline, just selecting the branch that it was happening automatically, all those steps. The artifacts are being stored for like a couple of weeks in our setup, so it's also like the first archive for some previous builds. And the biggest problem at this point was that the process of sharing was incorrect. So I've changed this part here on the right. I had the code review step, the runner built something. Someone needed to remember to share this in some way. It had a lot of course, problems because that someone needed to remember about that, needed to know to whom they should share this build. And also what? They should have the access to that build in some way, and you would need to like look at their hands if they are not sharing it through Google Drive, for example, which is not the best practice there. So next step was, let's try adding some automation for how to share and on which platforms would we share that. So we went for something, an important step. So the problem to solve here was how to control all those steps. Who will receive the build from which pipeline? Because you can have like multiple pipelines, like for example, one that you test something only on Android, one that will be built daily, and it's a daily build, for example, with like stable version that should be still stable. Where to store those built apps, because at some point the archive will get destroyed and you would want to store them somewhere long enough, of course. And how to, for example, to be able to modify whether it's a test build, master build, to build with some presets. We've selected a distribution platform. It was easy for us because we've been working with Firebase a lot, and for Android and iOS it was convenient. Of course, I think probably most of the platforms have some API to share those builds. We've been working with different ones. For our scale, Firebase was convenient because it's good for mobile. It's free to use at our scale and in a way bigger scale. When it comes to those functionalities like handling crashes or distributing apps, it's free. This was all the code that we've needed to add to share those builds into our account. So we've needed to create the account, preset everything, create some groups. So for example, a QA group that will be, some of the builds will be only shared to QA, some of the builds will be like daily builds will be only shared to QA. The ones that will be marked with something will be shared to everyone, for example, for testing. And I've just needed to know where the build is after everything. It's easy because when builder is executing, we are, for example, using shell variant. So it's just checking out the project on our builders. It was easy to set up and maintain, which is more important. So it was just in some location on the store. So a relative path was easy to get. And also those processes, those pipelines where they check out the project, they know what's inside of their area that's applied to the builder. So it's easy to like start from the root stage and get to some build, for example. Of course, sometimes we want to add some caching. Then I've needed to like tell Firebase where to get that. More important, how somehow pass the group ID. It was like easy. If I have those previous steps, I can just, for example, tell it that, for example, all merge requests with the name starting with Android will be shared only to Android devices. All that are starting their name with a release candidate will be shared to everyone, for example. And also like daily builds are automatically sent to everyone. Dev builds that are not in the main branch are automatically set to developers only, not to waste QA's attention too much. It was easy with like in one day, we had the builds in the Firebase app distribution. And when we've installed this into our devices, we can use the same view in Android and iOS just to download a particular build, browse through history, and download any previous build or try to simulate what will happen if I install the newer version of the app, for example, as well, increasing the number and see if like no data will break, for example, switching between them. So we've added this further part. Not only the builder was building automatically, but also the builds were being shared automatically to Firebase if I wanted them to. And also the builder was notifying the people, the folks, that either something is not correct, which is important for programmers shaming, to tell people that you need to fix something, or to let particular people know that, for example, okay, there is a new daily build for QA to do something with them. The next part was that at some point, it was easy when we were working, especially at the smaller teams, because with mobile, it's a lot that you don't need to attach all the people in the project to the repository. So we like for 5 developers and everything else happening in other way, it was not a problem because it was cheap. When we came to a point where there was like 20 or over 20 people, for every person attached to this process, we would need to pay like $350, and it scales up to infinity, and it's annual payment, so it's not perfect. There are alternatives. The main alternative we were looking for was switching to GitHub, for example, because it's way cheaper. It doesn't cost that much when you have bigger projects. But the actions there, so the alternative to the GitLab YAML specification, was more difficult to work with. The visualization was worse, and some of the functionalities already available in GitLab were not there. We didn't want to resign from that because the process already like took away some of the work. We could host our own GitLab instance on our server, but it was like not very efficient way of wasting attention of our developers. So fortunately, after some research, we found out that GitLab already has a feature that you can have your own project on GitHub. You can have just one license for like a master builder in the GitLab. You can attach those both sites, and it functions as a standard CI solution. So it provides those CI/CD options for the GitHub accounts as well. And we just needed one license for a year, which was visibly cheaper. And on GitHub, of course, like for this big team, it was like almost nothing to spend. So yeah, we came to the point that it was working again with a growing team, which was important because like for 20, 30 people and so on, it would just scale up to infinity. But then we came back to the problem that, okay, a build finishing the pipeline didn't tell us that much. And that was like the important part, because someone still needed to launch that. It was often that the QA opened the app was crashing at the start, for example, because Google libraries were missing some dependencies or something like that, or the data were incorrect. There were some issues with like commas in the value. Someone didn't check something, imported the new data for something in the game, and it didn't work. So fortunately, this was like the most important part after the easy one, to find out how we can automate the testing phase, because it's also easy, fortunately. We wanted to expand doing the builds into the next step. So if you have a correct build, it shouldn't yet allow to merge that code into the stable version. Let's check how the code behaves, and also let's try to mimic the player's behaviors and check if like no standard behavior in the application destroys something too much. So we wanted to first detect different kinds of bugs, or not only something not compiling and the build not appearing in the pipeline. We didn't want to waste QA time for testing things that are easy, like incorrect data, for example, which can be easily automated from the code phase. You don't even need to launch that Unity too much. And we wanted to shorten that cycle, not to like wait 3 hours for when the QA found finally time to check this PR, and then it didn't launch, so another 3 hours passed before the next test. We wanted to be sure that, okay, something that goes to the QA really should work. It's not always like that, but at least the easiest parts would be skipped. So fortunately, in Unity, you have the code coverage tests that can be both used for editor tests and for the playtime tests, and they are already like they have the API, or they have like command line commands that can enable them in the non-UI mode. You just prepare them. For example, we've prepared them as scripts inside of the project, like any other types of the scripts in any other programming language, for the code part at least. We've prepared like all those trees of tests and what will happen, what will be tested one by one. And you can tell the non-UI version of the Unity that's being launched during the pipeline. Okay, also do the coverage tests, for example, only for the editor or both editor and playtime, and give me the results back. If the results back are incorrect, something is not correct, I can either decide that, okay, this means that the pipeline failed because, for example, this was a master build and I wanted automatically abort anything further from that point. Or if it's a dev, I can, for example, send the report to our developers channel with full report of which tests didn't pass, and it's easy to track, okay, this happen at, for example, yesterday's build. Maybe something is missing. This is a modification of how we were executing the Unity in the pipeline. It was just a code for the execution, so we've added the part connected with the code coverage. We've applied the newest version of code coverage support inside of the Unity, and we've started doing the tests. So just we could visualize the edit mode tests here. There were some simple tests, like, for example, let's pass, I don't know, some commands to the UI manager and see if it will be able to retrieve a panel that at this point would normally spawn and be available for spawning. Yes, so for example, let's try load all addressables one by one for our panels and check if the main ones that we want to test are there. We could, for example, apply a custom save to, for example, some system, like, I don't know, to the quest system, and check if it still works, if it won't give back any incorrect data errors or anything like that. If any of those tests would not pass, they are just executed one by one and grouped in smaller groups. We could say that, for example, if this group of tests didn't work, let's give a warning to the developers, but not stop all the building process. Because, for example, maybe some data in the designs are missing. So this may be not so critical because, for example, it's often that like new characters will be not added to the project. Yeah. And the other ones, like the game is not starting at all. So the initial systems, for example, are not capable of initializing one by one as they would initialize at the start of the project. This is something that, of course, we would not want to pass to the build because this will be unplayable. This was the easy part, mostly like standard coding, like adding some asserts, putting some data into it. You can like read, for example, all the data from the file, try to parse them, and just throw errors if it's not happening inside of the test. And then if the results will come back, you can just apply some flag whether it should, how it should apply to the pipeline. Later on, which was more difficult, we'll also try to apply the play mode test because, of course, the data are most important. Without it, we can't launch the game. But for example, we had a lot of problems. Like, for example, someone was modifying the panels inside of the game, like an important, I don't know, shop in the game. And one button was missing because they forgot to reapply in the new asset that this should be a button, for example, or some script was missing when changing Unity versions. That's why we slowly but consequently moved into making the play mode tests, which were made in the same tool but in a quite different manner. The idea was that let's make it the most straightforward way. So let's launch the game, let's see whether it will load to the main screen, and then based on our system, let's try to mimic what may happen in the game. So, for example, we could test that let's load the developers levels. Yes, we have some preset levels. We know that what was the preset of the units that would normally pass the level, or preset of the units that will not pass this level. And let's check if in the new version it still passes this level or not. If not, maybe the like balance changed and this intended, for example, and we just need to modify the like final expected results. Maybe like you can't put the units in the game anymore because something broke in the code. So you just try to mimic the standard behavior. For example, going into the main menu, let's preset that, let's find all the buttons and try to press them one by one, just because why not? Let's go into the shop and let's try to make a purchase and test if it's with a correct test card, if the result is correct. It should be, if not, maybe something is incorrect. Yes, and the results of those tests, like with the edit mode tests, were reported back to the pipeline. So we could decide that, like normally, most of the time, if this test didn't pass, it was bad enough, and it is bad enough not to pass anything further, or just really closely check what's happening. Because again, sometimes it's just a balance thing, but most of the times, for example, we will get the information from one of the steps that this panel was working correctly. Now you can't exit it in a normal way, for example, or we are trying to go to load and unload all of the in-game levels, and for example, there are some levels that are not loading correctly because something like addressable was not built correctly, or some data for that level are corrupted, and so on. The problem was that, of course, the problem that is still existing, and it will always for us probably exist with play mode tests, they are quite often tedious to set up because you need to figure out how to play the game automatically. Yes, so of course you can just use the standard mechanics. So for example, if it's like a driving game, you can tell it, you can like record, for example, a player playing this development level and then replay that in an automated environment. But for example, they may be screen that a lot is changing there. A lot of new panels will be accessed from this screen. Maybe it's better to like collect everything on this screen, move back to menu after each step, and try to like force all the options on this screen to be tested automatically, for example. Yes. So you like for every screen that's important for you, you will need to come up with a solution how to play this in an automatic way. And the other thing is that it often takes a long time. For example, if you are just testing whether our levels can be passed with a preset unit, of course we can like speed up the game and we can use the cheats not to wait for something. But at some point you still need to wait some time. So the whole pipeline normally needs to wait this additional time. We have some more complicated tests that, for example, will execute only daily, so that, for example, everything will be tested in a normal environment with standard speed and so on. We can compare what will happen if the game is like five times faster, but then sometimes there are problems like when the Unity is executing in a non-UI way, sometimes things that will normally work in a project when it's running on the screen, for example, some single frames will be missing, and something that would normally give you a result that you want to do something later on, you will need to wait for that additional frame from code. So it's a lot of like experimentation and looking for those places that are really necessary and are not that necessary, and you will not want each developer to wait for those additional tests, additional like 5, 10, 15 minutes, 30 minutes and so on, because the more builds you will have, the more builders of course you will need to apply to go through them. When it comes to what do we check, yeah, as I've said, like loading a level, knowing some preset units that normally would pass this level, it's easy to check if it's still working. We can test purchases, we can check if just you can open all those characters that normally would be available, if you can put them into the game, for example, which is also important. If like data of some particular character, if you have a lot of them, really a lot of them, it's easy to miss that, for example, some designer broke something. Of course, there are also a test at the importer stage, for example, a separate from the pipeline, that will be testing if someone is trying to put into the project before trying to build that, if the data are correct. But the more steps we have, the easier it is to track like new types, for example, of issues that the previous test didn't detect, especially in the play mode, because it's often that the game is breaking. For example, when we're trying to go through the standard pipeline, get to the third level, for example, of the game, and this detects a lot of issues when, for example, after first level, some data were missing, and then we can't do anything. And additionally, later on, as we're adding more tests, we also went for detection of warnings, which is also quite useful. We can collect in the automated tests whether any warnings were in the project. We are trying to get as close to zero. It's normally not at zero. In the past, as any normal developer, we are of course not trying to fix everything, but then at some point it came to us that when we are, especially when using asset store based assets and code parts for some stuff, for example, like Easy Mobile Pro, in the past, it was often that the developers put the important things in those warnings, like memory leaks, for example, because someone used something improperly, or something is not still supported and should be changed into something new. Of course, if there was like 200 warnings, because most of them were like non-important stuff, like this value is not initialized with in a correct way here in Unity or something like that. Most often, as all developers, all of them were skipped, so no one was paying attention. Now, between every build, we of course are not blocking the pipeline when it happens, but we are tracking that, and we can easily detect when, for example, from one version to another one, in particular merge request, it increased, like for example, by 40, and something maybe is not correct. Maybe, for example, during the playtime test, something didn't go well with the loading of the data, and there are a lot of data missing, for example, or incorrectly specified in the design documents. And yeah, that was this part. So from standard pipeline, when we were building everything and sharing it manually and so on, we came to building the project, automatically detecting the codes issues. So if anything is missing in the data, for example, if standard systems work in the standard way, then play mode test, not to waste too much of the builder time, but if this part worked it should work in theory here. If this didn't work, then no need most probably to go further. Then if we've tested all those in-game standard users test cases, we went to sharing the builds and notifying all the teams that should test this build manually at the end, and hopefully it will work at this point. Probably everything. Nice. So yeah, thank you. If you have any questions, now is a good time. Yeah, I don't know if I should pass the microphone there or.
Hi, thank you. Just single question. Did you use Blender? So .blend files, because there is some issues using game CI and the blend files. So probably you need a version of a Docker image or something like that with Blender itself or something like that.
Like we had blend files, but we didn't test them yet. So if something was missing, it was on the project side, but we didn't have problems yet with like blocking pipelines or something like that. So I'm not sure what kind of problems would appear. When it comes to the art, we most often test that on the project side. For example, we had different approaches to that. First thing is you can easily browse through all the assets that are attached to panels and everything and in-game units, for example, and report any places where there should be something and there's not something. The other way, we were testing that in projects that were changing a lot for a big player base. We were often like doing, for example, automated screenshots for stuff so that art team could easily check how those assets that they are creating are actually looking on a mobile screen, because it was not always, for example, they often didn't need to be that big when created.
So you had some screenshot testing in place?
Again,
You had some screenshot testing process automated.
it was automated screenshot preparation, but the testing of screenshots was on the art part. It was not like they were not doing this every day. Not like, to be honest, the art or design, of course, never want to use those tools too much. So it's like every week, for example, it's important to, before we prepare the master build, for example, or a big part of art was added, these are the important points to check if it's everything's correct. If, for example, like no graphics were missing, because, for example, if you are reusing the graphics between a lot of windows, there are sometimes windows that everyone forgot about them because this mode was not developed for a long time, and it's easy to miss something at those places.
Yeah, because we had some automation, like you can provide like an initial screenshot and then a ratio of the difference of the screenshots, and all this automated, and then you will notice definitely when there is a model missing, which in our case, for example, is because of Blender missing transpilation to the FEX files and all that. Yeah.
So didn't try with Blender to do such tests, unfortunately, yet, but the screenshots difference is a good idea.
Okay, thanks.
I don't know if you should.
Oh, thank you. Um, uh, I was wondering how you deal with asset refactorization, for example, scriptable objects, changing things where when you need to move a set of parameters into serializable, for example. Do you use programmatic methods to mass update all the resource files? And if so, do you also freeze all these assets? When you do such a thing, because otherwise problems will happen.
So when it comes to scriptable objects, the main thing is that, unfortunately, we quite often just not use too many of them, because we use them when we need them, but it's often that they generated a lot of those problems. But of course, later on, as we wanted to use some of them, we moved to, like, normally when we work with scriptable objects, we just always, when something is edited in them, or, for example, when something is loaded into them, we still store XML or JSON representation. It's happening automatically, for example, on the import of the data, or whenever the designer would save the results of their work and try to send this to the repository, then all those data are exported to, for example, JSON format, so we can easily detect the differences, for example, between them, or if something's missing, because it's the easiest. There is no like mismatch that something changed and no one noticed that if it's like the text, and it's easy to for the automated test to compare what changed between versions, for example, what the designer is trying to apply.
May I extend the question
Mhm.
to prefabs and mono behaviors? Do you have if you need to mass change mono behaviors in prefabs? Does
So
this happen or it doesn't happen?
yeah, I mean, when it comes to mono behaviors, we normally try to work in a model where Unity is used the least, as little as possible. So of course everything is put into the prefabs, and everything is instantiated, and like scene is like 5 game objects, and then everything is generating and everything is tested and so on. So we just try not to have like objects on scene, for example, that may disappear. They are always generated from some patterns, so from prefabs, for example. It's easy to, for example, browse through all the prefab contents, because that was something that was often between versions. For example, some prefabs could disappear or have invalid data, invalid connection to scripts, for example. So that was something we were testing. But normally we try to like minimize the amount of things that are inside of the scenes, for example. They are most often either packed into some addressables, for example, so it's easier to compare with something changed in size. Like every panel is split into the prefabs, of course, so they are always instantiated. It's easier to test if everything is okay with those panels just by browsing through those, by doing screenshots, by browsing through all the elements that should be inside of them. And the same when we are trying to instantiate this in some new place. We have always like this occasion to test if everything is correct, if no one forgot that this prefab is used somewhere, so that we don't need, for example, to like launch every scene and test everything, because we have like 2 scenes, for example, for all game. One is the pre-initialization phase, where we want to ensure that all systems have connection, all data are correct, and so on. And then the game is happening and the states kick in, so it's easy to determine where you are currently. It's like game with a lot of systems, so it took us some work to do this architecture, but it's easier to maintain in the long run. So that's why like everything is split. Nothing is like flying around the project in separate scenes, for example.
Thank you very much.
Hello, thanks for the talk. You were talking about app distribution with Firebase. How does that work with Google Play and App Store? Is it implemented that you also implement all the builds there, or is this completely skipping that part and you implement uploading those builds to stores separately? Or
So yeah, the pipeline is going and it's uploading this to Firebase, so people can test if everything's okay. We have next step, which just have a couple lines of code. It's also a simple API that can preset, for example, the iOS certificates and everything, and just send it to the store to be ready to release. And the same with the Google Play. It also can, like, either on Firebase you can easily add, for example, descriptions, and you can also pass that further with translations to the Google Play. So yeah, so it's on the builder side. It's not on the Firebase side. The Firebase is just a step, and then we are going back to builder. But this is most often a manual step because it's a master build. So someone needs to give an okay, and then we have next step. Okay, send this to our all stores or one store, depending on what we want.
okay, thanks.
Hi, thanks for the talk. I'm interested in the runners. Where you ended up having your runners? Are they on GitLab, GitHub, or do you have it on a server, or you have your own physical machine?
So because we are using GitLab, it's easy to install all kinds of runners. we first were using the online runners. Then we were trying to like evaluate and think if we can move them to the virtual machines, which is possible. But we've ended up with our ones in a couple of places because it's remote, so it's easy to split them in multiple places. When you group them correctly, if any of the runners is down, it's easy to switch between them and share the workload, for example. So the physical ones were good for us. In the previous project, we had mostly virtual because it was like the iOS was most difficult to virtualize then. So I would say, but it's like the API is simple, so you can easily rent, for example, the cloud runner somewhere. There are a lot of services like that.
Yeah, okay. And now the real question I'm interested in: how big, how many people on the team know how to service this machine, how to maintain them? Yeah, what happens if someone is sick, someone goes on holidays? Yeah, are there any downtimes due to things like that?
I mean, if it's very critical, we just can always come back to the standard pipeline and disable them. So sometimes it happened in the most critical cases where it was an early stage that we just, okay, today we will be just doing the standard pipeline and test when it will be back. Now, normally it's not a problem. That's why we're working a lot on simplification on those steps, so that there is not that much code executing that outside of the Unity, and as much of the things are inside of the Unity, because a lot of people, all of our people know Unity. Like I think 3 people are capable of maintaining that. So if all of them will disappear, it will be not good, but hopefully it will not happen. So we just go for the simplest solution, like using the most standard functions, as much from the system as it's readily available at the start, and looking for those options that we don't need to install a lot of custom solutions and like set up a lot of strange variables, so that everyone that will just need to, like if all of the runners will burn, it's easy to set up a new one, for example, on a standard new Windows machine, for example, or iOS machine. That's not a lot of steps.
Okay, thank you.
Okay, so that's everything. Thank you very much for attending and have a good day.